I think we can start, right, Partha? Let the people, I think, join the middle. Great. So, good morning and good afternoon. I think we are from the different places. So, hello everyone. A very warm welcome to all of you. And on behalf of the Paleo ECR India community, I, Arvind Shukla, from the event coordination team, very much delighted to welcome you all for our first talk of the Paleo ECR India Saturday Talk Series. And this talk series has been initiated with the aim of creating a collaborative platform for early career researchers and senior scientists to share ideas, research experiences in the broad field of paleosciences and earth system sciences. So, as we are also approaching to the end of the year, we are especially pleased to conclude this year with the first talk of our Paleo ECR India Saturday Talk series. And we hope this initiative will set a positive tone for all the year ahead and nurture meaningful scientific exchange within our community. We are very pleased to see the participants joining from different, I think, regions and different institutions. And your presence today is very much special for us as this inaugural talk will marks an important, milestone for all community. A few announcements that I'll request everyone to please keep your microphone muted and during the talk and use the chat box for any kind of communication. So we will have a 30 or 35-minute talk and then a 15-minute dedicated session for Q&A. And so you can put your questions in the chat box or you can raise your hand and our coordinator will reach out to you by one by one. Great. So it's my pleasure to introduce our speaker for today, Dr. Upasana Banerji, as she is a distinguished paleoclimatologist with a strong background in earth science and marine science. She completed her master's and bachelor's in geology from Gujarat University and earned her PhD from MS University Vadodara while working in Physical Research Laboratory, Ahmedabad. So Dr. Banerjee has been associated with many prestigious national institutes such as Ministry of Earth Sciences Delhi and National Center for Earth Sciences Studies. And if you talk about her research focuses on the past climate variability with the particular emphasis on the Holocene climate change and dynamics of the Indian Summer Monsoon using geological and geochemical record. So we sincerely thanks Dr. Banerjee for accepting our invitation and for sharing her time and expertise with the value we share in the community. And she's going to deliver a talk on the Abrupt Climatic Events, ACE, of the Holocene Epoch and the Indian Summer Monsoon. So with this, I invite Dr. Banerjee to begin a talk, and the floor is yours. Thank you, everyone, for joining us. I think let's begin. Thank you. So I'm going to stop sharing my slides. And yeah, please do share your slides.
Just a second.
Yeah, perfect.
Is it visible? Are my slides all
Yes,
visible?
yes.
It's visible?
Yeah. Just
Okay.
keep it and keep it.
Thank.
Yeah.
Can I keep it in? Okay. Is it visible now?
Yes, yes, yes.
Yes, sir. Firstly, thank you, Arvind, for giving me this opportunity, and thank you all for being here to attend my talk. That makes me a little scared. Good morning and good afternoon, and warm welcome and belated Merry Christmas to all. Well, to begin with, I would say that the human civilization for centuries, they have coexisted nicely with the nature. But when we talk about climate change, since last two centuries, there has been tremendous exponential change in climate, And that happened because of the interference of human impacts within the natural variability. And because of this tremendous change, people have started working on climate models and trying to project it. But the major setback that has happened is because we are unable to discriminate the human interference from the natural variability, firstly. And secondly, we do not have sufficient instrumental records. It hardly goes for last 2 centuries. And that is where our paleoclimate studies plays a major role. Since this is the first Paleo ECR talk, so I thought of giving you brief history of paleoclimatology. So, generally, it is considered that paleoclimatology subject began in 17th century when Robert Hooke first, he was an English physicist, but he argued that there was a warmer climate than the present in some time in the past based on some huge ammonite fossil. And that was the kickstart of paleoclimatology. Following this, in 19th century, the discovery of glacial interglacial cycle by Louis Agassiz paved the foundation for the understanding of greenhouse gases and climate change. While in 20th century, people started combining paleoclimatology with other sciences like geology, biology, physics, etc. In late 20th century and now the 21st century, people have started using computer models for past simulation and future climate trends, and which is still going on, of course. And now people have started using machine learning and artificial intelligence for the same, and the work is significantly going on. But the major setback again begins because of the lower temporal and spatial resolution of climatic records. Since we are talking about the near future, so it is important to understand the nearest past, that is the latest interglacial period, that is the Holocene. I've been working on Holocene climate variability for last few years, so I thought of discussing about the abrupt climatic events within the Holocene and the Indian monsoon response towards these abrupt climatic events, which I term it as ACE of Holocene. Fortunately, for our just a second, what happened? Fortunately, we have various natural archives like for that provide a good amount of Holocene climate changes, such as the corals, paleotherm, ice cores, sediment cores, etc. So for today's talk, I'll begin with some introduction where I will give the details of some selected abrupt climatic events of Holocene, some details of Indian monsoon system, how monsoon varied during the Holocene epoch, its possible global teleconnection, some inferences, knowledge gap, and the benefits of studying these paleoclimate records. When we talk about Earth is basically a vast heat engine where the solar energy is evenly distributed from tropics to high latitude through two major processes. That is the global atmospheric circulation, and global ocean circulation, which is also known as the thermohaline circulation. A small tamper in the circulation system, a small change in the circulation system causes climatic change in the climatic episodes or causes abrupt climatic events. And Holocene has been a great example where such changes are being observed. Well, Holocene, though it's a latest stage, but there has been some attempts to divide the Holocene period. And the first formal division was based on some palynological records wherein the Holocene was divided into pre-boreal, boreal, subatlantic, Atlantic, subboreal, and subatlantic. Following which, Bond and group, they studied the ice-rafted debris from North Atlantic region and identified approximately 10 cooling events, and which was resulted due to the weakening of ocean circulation. And these bond events, they found it to be showing a cycle of nearly 1500 years. It was a 1500-year cycle After every 1500 years, these bond events could occur. But the major success occurred when a formal ratification of Holocene Epoch was done in 2018, based on two abrupt climatic events, the 8.2 kiloyear event and the 4.2 kiloyear event. Of course, it was not done by just one group, but it was a process. Like a sub-commission of quaternary stratigraphy, they initiated it. Then International Commission of Stratigraphy, they approved it, and formal ratification is done by the IUGS. When we look into Holocene epoch, it ranged from till 11,000 years, and it is divided into three major stages: the Meghalayan stage, the North Cripian stage, and the Greenlandian stage. The North Cripian and Greenlandian stage is divided based on event called 8.2 kiloyear event, and this event is very much registered from the Greenland ice core as a cooling event. Now, this event occurred as a function, as a result of sudden influx of fresh water from Hudson Bay near North Atlantic region, which weakened the ocean circulation, thereby resulting in a short cooling event. Now, this event occurred for around 160 years. The next was the Meghalayan stage, which was identified from the Meghalaya, from the speleothem of Momlu Cave in northeast India, Meghalayan state. Now, this event, the 4.2 event, basically it began around 4,300 years and terminated around 3,800 years. Whereas its intensification, it was observed as a weak summer monsoon event, extremely dry, arid event. It prevailed, and its intensification occurred around 4,000 years before present. Now, when we talk about the Meghalayan stage, of course, it began from 4.2 kiloyear event, but it is followed by a lesser known climatic event known as Minoan warm period, which prevailed around 3.5 to 3.2 kiloyears, which was followed by the last two millennia climatic events. The first millennium is identified as the Roman warm period and the Dark Age cold period. As the name suggests, the Roman warm period was identified as a warm, and Dark Age cold period was identified as a cold period, as a dry or cold period. Now, with this Dark Age cold period, there is another short climatic event occurred, which is termed as the Late Antique Little Ice Age. Now, this climatic event has been associated with the volcanic forcing. Looking into last millennium, well, it is very well studied globally, and it is broadly divided into medieval climate anomaly, Little Ice Age, and the modern warming. Little Ice Age is also famous for the frost fair, which occurred over the River Thames when the River Thames got freeze, and people enjoyed a fair over the River Thames. And the modern warming, which is one of the pressing issue these days about the global warming, and that has got a lot of human interference, and identifying the natural variability has become a little difficult. Now, these climatic events globally observed, but their signatures, how it has impacted Indian climate system, that we are going to discuss. Now, the Indian climate is basically controlled by the Indian monsoon system, and the Indian monsoon system is controlled by the intertropical convergence zone. Intertropical convergence zone is nothing but a narrow latitudinal zone of wind convergence, the trade wind convergence zone within the tropical region. And the dramatic shift of this ITCZ, the intertropical convergence zone, leads to Indian summer and Indian winter monsoon. But the major factors the major factors causing Indian monsoon is the differential heating of land and water, the lateral shift of this ITCZ, and the pressure zone near the Madagascar. Because the more pressure difference will be there, the better we get the monsoon over India. When we talk about Indian monsoon, The Indian summer monsoon is the dominant Indian monsoon system that causes more than 80% of rainfall, and it occurs between June to September. It has got two branches, the Arabian Sea branch and the Bay of Bengal branch. During peak monsoon season, when the ITCZ gets stabilizes in the near in the region where the ITCZ gets stabilizes during the peak monsoon season, that is nearly July and August, that zone is considered as the core monsoon zone, the CMZ, and it represents the annual Indian summer monsoon intensity over India. While the southward migration of the inter ITCZ leads to northeast monsoon as well as the western disturbances. Now, the northeast monsoon is basically associated with the Siberian high, which causes dry air coming towards south, and when it go moves over the Bay of Bengal, it carries moisture from Bay of Bengal and causes rainfall over Tamil Nadu region. So the Tamil Nadu region exclusively experiences northeast monsoon, while western disturbances is associated with the extratropical wind system, which carries moisture all the way from Mediterranean region and causes rainfall in the northern India, especially the Himalayan region. So basically, we can divide our Indian subcontinent into core monsoon zone, northern India, peninsular India, while peninsular India divides the two distinct basins into Arabian Sea and Bay of Bengal. Because of so many kind of rainfall happening within Indian region, we have various tremendous variability of tremendous variability of Indian monsoon. Of course, people have tried to address this, but still the understanding of Indian monsoon response towards these globally observed abrupt climatic events remains either poorly studied or remain unaddressed. So today we have two objectives. One is to understand the response of monsoon and climate towards these observed abrupt climatic events of Holocene, and we will also try to decipher the role of natural forcing and climate variables on these on the monsoon Indian monsoon system. So to begin with, we'll see a look into the core monsoon zone. Well, within the core monsoon zone, two lakes from Haryana, that is Rivasa and Kotladhar, have shown prominent weakening of Indian summer monsoon during 4.2 and 8.2 kiloyear event, while Lonar Lake, which is located in the southern region of core monsoon zone, has not shown any major change during 8.2 kiloyear event, but definitely it responded well towards Bond event 4. Additionally, Lonar Lake has also not shown has shown dry climate during medieval climate anomaly. On the contrary, uh, this Dew Island, Dew Mudflat has shown strong monsoon during medieval climate anomaly. Simultaneously, this Dew and Null Lake, located in the Western India, has shown a monsoon spell during 4,000 to 3,000 years, which probably indicated the prevalence of monsoon during Minoan warm period, while it was followed by a dry climate. And the Rishikulia River showed a gradual decline from a decline in monsoon from 3,000 years before present. So basically, we can say that within the core monsoon zone, there has been variability in response of summer monsoon towards the abrupt climatic events. Now, looking into the northern India, the signatures of bond events are well observed as a weak monsoon zone, as weak monsoon event in case of Sahiya Cave and in case of Benital Lake, while the 8.2 and 4.2 are well registered as a gradual weakening of monsoon in most of the cases, and definitely it also showed a prominent signature of 4.2 by our Momlu cave that is located in the northeastern state. When we talk about peninsular India, most of the peninsular India has shown weakening of summer monsoon during the Little Ice Age, while the signatures of bond events are not much recorded, but even if it is recorded, it has always been recorded as a weak monsoon event. And talking about the Minoan warm period. Minoan warm period is not recorded anywhere as such, except for the Vellini Lake, which is located in the southwestern India. Looking into the marine records, well, overall, there has been a strong summer monsoon during early Holocene in both the cases, demonstrated by both Arabian Sea and Bay of Bengal. But in case of Arabian Sea, it has been identified as increased productivity, while in case of Bay of Bengal, it has mostly been identified based on increased terrestrial contribution because of the Ganga Brahmaputra sediment contribution. While the signatures of 8.2 has been more prominent in case of Arabian Sea than in case of Bay of Bengal, except of course Andaman Sea. This could be because the Bay of Bengal also receives northeast monsoon, so it might have partially suppressed the signal of 8.2, but that doesn't mean it has not shown. Definitely, it has shown the signatures of 8.2 even. While 4.0 has been observed in both the cases. Now, looking into the Minoan warm period, well, of course, it is not well studied yet, but whatever study has shown, it's like mostly the the proxies from southwestern India, and as well as northern in western India, as well as a record from northern region has shown the Minoan warm period. That means there is some specific mechanism acting on the Minoan warm period, and it is not only the summer monsoon, but some additional mechanism is there. Now, looking into the last millennium climate, well, the medieval climate anomaly has been observed as a strong summer monsoon event as the result of stronger solar influence, while a discrepancy is observed wherein the northern Indian records have shown wet climate during Little Ice Age, while the peninsular India have shown dry climate as a result of weak summer monsoon. So there is a discrepancy within the Little Ice Age, while the modern warming during last 200 years, it has mostly been seen as a warm climate rather than a wet climate. But still, there are a lot of discrepancy that needs to be addressed because it also included the anthropogenic influence within the natural variability. Summarizing these observations, we can say that early Holocene has been prominently dominated by Indian summer monsoon with a gradual declining trend. The events like 8.2, 4.2, and Little Ice Age, if at all, has been registered as a weak summer monsoon. The Roman warm period and medieval climate anomaly are either seen as a monsoon strengthening or remained unregistered. But in Lonar Lake, it has been observed as a dry climate. The medieval climate anomaly has been observed as a dry climate. Now, the Little Ice Age in northern region was observed as a wet climate, while most of the peninsular record have suggested dry climate as a result of weak summer monsoon. And the sites located at the northern extent of intertropical convergence zone seems to be more sensitive towards the globally observed abrupt climatic events like the 8.2 and 4.2 event. Now, the question arises, what causal mechanism acted during these prominent abrupt climatic events of Holocene epoch? What mechanism led to the monsoon during Minoan warm period and in selected regions? If it would have been only the Indian summer monsoon, it would have been observed in most of the records, but this is not what we are getting it right now. Why did the peninsular region witnessed a dry climate, but a wet climate prevailed over northern India? Why there is an inhomogeneity in case of little ice age climate? And the major question arises if the 4.2 is observed as a dry climate, why not wet? Though there or why not an inhomogeneity like the little ice age has witnessed? To answer these questions, it is important to understand the climate forcings. Of course, the major climate forcings are the orbital forcing, the solar forcing, and the volcanic forcing. Definitely, the greenhouse gases and the land use cover is also one of the important forcing factors. But when we look into, but greenhouse gases has been more impactful during last 200 years rather than the entire Holocene. And when we look into Holocene, these three factors has been more impactful. So what happens here? How does it change the monsoon? So the climate forcing impacts the ocean atmospheric processes. The change in ocean atmospheric processes leads to change in the position of the intertropical convergence zone, and the change in the intertropical convergence zone leads to change in monsoon and thereby leading to major climate variability. So when we talk about ocean atmospheric process, this is an excellent example of reconstruction of El Nino Southern Oscillation in the past. So now what they have done is, in general, in the equatorial Pacific Ocean, the trade winds blow from west to east, and which pushes the warm water from west to east, thereby causing high biological productivity over here because of the upwelling and rainfall along the Australian side. This happens under normal conditions, but because of weak trade winds, they are unable to push the warm water, and warm water accumulates over here, causing extensive rainfall. Now, a laminated core was collected from a Peruvian lake, wherein the light color has been associated with the rainfall event, and it has been linked with the red color intensity, and the dark color was associated with the high biological productivity. That means the more light colored lamina represents more El Nino like conditions. And based on this, they reconstructed the red color intensity and identified that after 7,000 years, there was an extensive increase in the El Nino events. Similarly, there is another interesting example of ITCZ reconstruction, wherein a laminated core from Cariaco Basin was retrieved from this region. And now the Cariaco Basin is located in such a uniquely placed, that is it is located at the northern edge of annual latitudinal range of ITCZ. So in summer, the ITCZ is over this basin, causing extensive rainfall, thereby increasing leading to the transportation of increased terrigenous material, thereby increasing titanium concentration. While the southward migration of the same ITCZ diminishes the rainfall, and thus decreases the terrestrial contribution. So whenever we are getting high titanium concentration, which indicates increased terrestrial contribution as a result of northward migration of ITCZ, while towards south it shows the while low titanium shows southward migration of the ITCZ. No, before the beginning of before the onset of Holocene, the younger dryas has seen such extensive southward migration of ITCZ, and more or less a similar condition occurred during the Little Ice Age. That means there was a southward migration occurred during Little Ice Age. But when we talk about Minoan warm period, it has shown some kind of fluctuations. That means there was the event of southward migration of ITCZ. But when you look into 4.2 kiloyear, as such, there was no major change in the ITCZ position. This is another example where the Greenland ice core has been used to address or to understand the Siberian high and the North Atlantic oscillation. Now, in the Greenland ice core, the potassium content acts as a proxy for long distance transport from Asia, and which is a result of Siberian high. So more potassium will lead to deposition of more potassium deposition in the ice core will suggest stronger Siberian high, while more sodium content in the core will suggest stronger North Atlantic oscillation. So, within last 10,000 within the Holocene period, the 8.2 event has been observed has seen both a strengthening of Siberian high as well as deepening of Icelandic low, that is stronger North Atlantic oscillation. In case of Little Ice Age, also a similar thing has been observed, and even in case of Minoan warm period, also there was a stronger Siberian high and deepening of Icelandic low. But when we look into 4.2 kiloyear event, only the Siberian signatures of stronger Siberian high is there, but no major change in the Icelandic low has been observed in case of 4.2 event. Collating all these records and combining it with some solar insolation and solar forcing as well as the hematite stain grains depicting the bond events. What we have observed, what we see is there was the strong summer monsoon during Greenlandian stage was a result of strong solar insolation as well as orbital forcings. While you see some enhanced volcanic event during early Holocene. Now you must be thinking that it should have impacted the monsoon system, or it should have reduced the monsoon system because of the volcanism. But actually, this volcanism occurred was not a normal process, but it occurred because this was the time when the climate was transitioning from glacial period to interglacial period, which resulted in a lot of readjustment in the crustal stress due to unloading of glaciers. So these volcanic events occurred because of that. Now, during 8.2 event, both Siberian high and Siberian high, as well as the North Atlantic, the Icelandic low, deepening of Icelandic low, corroborated with the weakening of thermohaline circulation, that weakening of ocean circulation. So 8.2 very well associated with that. While the Minoan warm period has also witnessed both Siberian high as well as North Atlantic oscillation, and it also seen some events of this deepening bond event. So, which means the whatever as we are getting stronger monsoon at selected locations in the Minoan warm period, it could be because of the combination of both summer and winter monsoon, and not just the strengthening of summer monsoon. Otherwise, we wouldn't have got this increasing values of potassium in the JISP ice core. Now, looking into last millennium, the medieval climate anomaly, the strong monsoon during medieval climate anomaly has been associated with the increase in the solar insolation, while um, a volcanic event occurred around 750 years ago, along with the lowering of solar forcing possibly kick-started the onset of Little Ice Age because these events led to southward migration of intertropical convergence zone, thereby causing weakening of summer monsoon. But because it was so strong, strong migration occurred during ITCZ, that the northern Indian region also witnessed influence of winter precipitation in form of western disturbances. So the northern India experiencing winter precipitation was because of the strong western disturbances. Now, talking about 4.2, it is the most conspicuous and most debatable event because there was a stronger Siberian high occurred, but no major change in the ITCZ or no major winter precipitation occurred. In fact, there was extreme dry climate prevailed over India. Now, to answer this, there is a paper where Oral et al. Have suggested that during this time period of 4.2 event, there was a strong Siberian high, which actually they have made this hypothesis that have actually blocked the moisture coming all the way from Europe and westerly winds, which resulted in because of which the Indian subcontinent witnessed that dry climate, but it could not had the influence of winter precipitation. And because of this, the entire Indian subcontinent remained dry during 4.2 kiloyear event. While a recent paper suggested that it's not the 4.2, but the 8.2 kiloyear event have been more prominently registered as the abrupt climatic event of Holocene than the 4.2. But if we look into Indian records, the 4.2 are more significantly registered than 8.2. No doubt there are signatures of 8.2, but 4.2 is more frequently observed. Now, it is important to understand the exact mechanism for these abrupt climatic events. To start with, it is important to address 8.2 and 4.2 events. We have a recent paper wherein the 4.2 event was suggested. They suggested that though most of the records have found 4.2 as a dry event, but there are studies which suggested wet climate, especially from Europe, Africa, and parts of China. So the exact mechanism acting during the 4.2 has remained is a major debate throughout. So the inferences that we have drawn from the present talk is, firstly, there was a strong summer monsoon with a gradual declining trend, and it was because of strong solar and orbital forcing. Both 4.2 and 8.2 event are observed significantly in the region that witness the northern extent of intertropical convergence zone. So those locations responded well towards these two observed events. The 4.2 was possibly because of stronger Siberian high, but that is still a debate and needs to be addressed well. Talking about Minoan warm period, this Minoan warm period witnessed the occurrence of both summer and winter monsoon. It was an interplay of strengthening and weakening. It's like an oscillation occurring between summer and winter monsoon, and that has to be discriminated by studying each of the locations that experiences that particular monsoon system. Talking about last 2000 years, the Roman warm period and medieval climate anomaly has witnessed a strong summer monsoon, and which was mostly associated with the solar forcing. The DACP event is not well studied from Indian records, possibly because of the resolution. But whatever studies have reported, they have reported it as a weak monsoon system. And within the DACP, there is a late Antique Little Ice Age that has been linked with the volcanic forcing. Talking about Little Ice Age, the Little Ice Age, there was a weak summer monsoon with strong western disturbances, and it has been associated with the volcanic forcing as well as the solar forcing, along with the weakening of solar forcing. The modern warming remains again a question mark because it has got influence of natural as well as human impacts, and that needs to be discriminated well. So we need to have a high resolution study for last at least 2 to 300 years combined with instrumental record to discriminate such process. Though there have been significant study, but still the question that remains unsolved is how do these ocean atmospheric process impact the Indian monsoon system? What mechanism connects and links this high latitude and low latitude climate system? How Indian Ocean and Indian monsoon generally interacts with other monsoon system and within themselves, and what natural forcing mechanism leads to such change in the Indian monsoon. If we are for answering this, we need extensive high resolution spatial and temporal data sets. But if we are able to address it, definitely we'll be able to understand the natural drivers and variability well, which will help in preparing the foundation and understanding the present warming trends. Will be able to distinguish between natural and human forcing. If we are able to distinguish the natural and human forcing, we'll be able to have improved protections and risk assessment policies. And the better resolution we have, temporal as well as partial, it will help us in improving the simulation and future climate projections, which in turn will help us in providing policy and adaptation planning. Thank you so much. And if you have any question, I'll be happy to answer.
Yeah, so thank you so much, Dr. Upasana Banerji, for your just such. I think this is one of the very detailed talk about all the climatic events, like the major climatic events in the Holocene. I think if someone wants to have like detailed information, he or she should visit to this talk. So now the floor is open for the Q&A session. If someone is having any kind of doubt, any questions, please do raise your hand. Yeah, Salman, please unmute yourself and you can directly ask the question.
Hello, can you hear me?
Hello? Yes, yes, please.
Hello, thank you, Pasna,
Hello.
for a wonderful talk.
Thank you so much.
This is Salman from NIO Goa.
Okay. Hello, Salman.
You well defined the structure of all the climatic anomalies during this Holocene. So it was really wonderful. So my question is about cold climatic anomalies.
Okay.
Okay, it's about like signal propagations. Like there was a meltwater pulses in the North Atlantic that lead to the changes in thermohaline circulations.
Correct.
So during all these climatic anomalies, we have cooling in the northern hemisphere and the reverse signature in the southern hemisphere.
Correct.
So most of the people believe that this signal propagation, which has impacted the Indian monsoon due to
Correct.
this cooling effect.
Correct.
Okay. So was it just propagated through thermohaline circulation, or there was any like atmospheric teleconnection also? What has contributed more?
See, you cannot quantify whether which process has been more impactful, but it is always a feedback mechanism. Like because from thermohaline circulation, it has definitely propagated. But in addition to that, there will be change in atmospheric process also. So it will be a gradual feedback mechanism. So it also depends on how much time period your climate prevailed. Firstly, and secondly, it is also said that the from northern hemisphere, from higher latitudes to tropical, the climate propagates within a few decades to century. So
Yes.
if the climatic event is longer, it will be easily registered, and that is the problem with Holocene. Because if you see LGM, we find LGM signatures everywhere, mostly,
Yeah.
right? But when you talk about younger dries, we don't. We have to find younger dries as well. It's not that uniformly you will get younger dries, but since it was a longer time span, we still get the records. But when you come to Holocene, the climatic events, like I said, 8.2 event was for 160 years. So for registering it, it has to prevail for a longer time. So that's how it happens. Uh,
Mm.
did I did I answer your question or I made you confused?
No, 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 it's clear. It's clear. Almost clear. Thank you. Thank you so much.
Okay, thank you so much.
Yeah, anyone else? I think we have one question from Anand Rajoria. So I will just
Yes,
read out the
please.
question. Yeah, if you can see this.
You mentioned that this drought phase intensified, but there are records of which are deeper. Okay, Anand, this is a wonderful question. And for me, I would believe since there was you're getting a wet phase in Tamil Nadu record. It could, since the 4.2 event was associated with your Siberian high, as I've already shown you in I score. So the Siberian high generally leads to strengthening of northeast monsoon. And as you're saying, Tamil Nadu record has shown wet phase. That means there could be some records of strengthening of northeast monsoon, which led to which resulted in wet 4.2 kiloyear event. So this would be my hypothesis for that. But definitely the 4.2 is a mystery and that needs to be addressed well. But I believe it could be because of the strengthening of Siberian high, because only the Siberian high can Siberian strengthening of Siberian high is observed during 4.2. So that could be that is would be my hypothesis for that.
Yeah, Partha, please.
Can you hear me,
Yes,
Arvind?
Partha, please. Yes, Partha.
Upasana di,
हाँ बोलिए.
thank you for the talk.
Thank you
And
so much.
maybe I'm hearing you after 6 or 7 years after PRL. So it was really nice to listen to your talk.
Okay, thank you.
So I have a question like that can be divided into two parts.
Okay,
First, actually, what exactly drives these abrupt events? I mean,
okay.
maybe we can say it is meltwater fluxes again. I mean, what really drives those meltwater fluxes in North Atlantic? And second one is if they are abrupt events, I mean, by studying them, can we really talk about the future, or they are really abrupt and come at any time?
Okay. Can you repeat the first question? It was too long for me.
Okay, okay, okay. The first part is like what really drives these abrupt events. I mean, maybe it
The
is
meltwater.
meltwater flux. I mean, then has sun's any kind of role in it, or it is purely random?
No, no, no. See, sun has got its own cyclicity.
Mhm.
But suddenly it cannot have, sun cannot suddenly create an abrupt event because it has a cyclicity of 11 years, 11 years. So the event will be gradual. For me, I believe that the abrupt event is the meltwater flux. That is a sudden influx of fresh water, and suddenly we are stopping the process. So something related to within the earth has to be the major reason for such abrupt event, right?
Okay,
And
okay,
your some internal process, and then it's a feedback mechanism that goes on. But that event has to sustain for at least some 1 or 2 century to continue it. To because it's not that today it started and after 10 days it's not there. So the feedback mechanism will carry forward. It is the responsibility of those mechanisms to carry forward the event. And
okay.
what was your
So,
sorry? And okay,
okay, okay. So, is it like it is a combined effect of multiple complex processes? Is it
yes,
like that?
I would say
Okay.
that. I would say that. Yes.
Okay, okay, okay. And my second question was like, if they are really abrupt, by studying these past events, can we really talk about something in the future, or they can happen at any time?
Okay. Uh, See, future projection, so definitely I'm not into it. But one thing I can say that if we are able to address these abrupt climatic events, so suddenly we are getting sudden torrential rain or some extreme drought. So those events maybe will be able to address it well rather than it became a surprise for us कि अरे कहाँ से आ गया. So maybe these events can help us in addressing those abrupt events that can occur in future. Because finally, see, personally, I believe that climate is a cyclic process. It has its own cyclicity, it has its own wave mechanics and all. But only thing is we are unable to address it because we are working on bits and pieces. So those pieces has to be collated, has to be joined in such a way that we have a perfect network, perfect diagram, perfect picture of that particular system. And main drawback for our Indian subcontinent is we are witnessed or hampered by a lot of process. It could be El Nino, it could be North Atlantic Oscillation, it could be normal Indian Ocean system, it could be your summer monsoon, winter monsoon. So a lot of processes are happening with India having varied topography. So because of these continental and atmospheric and oceanic process creates a lot of confusion and makes it more complex because it's always easy to address in not in that region and all.
Okay,
Yes.
Yeah, okay, so yeah, please.
okay. Let me just finalize it in one sentence if I understood it correct. Like
Okay.
it's like rather than when it will happen or not, it is at current we are more interested in if that happens, how all these climatic systems will respond to that.
Yes.
Okay. Okay. Thank you again. Thank you, personally.
Thank you, Partha. Thank you so much.
Okay, so we have
Hello,
Dr.
hello. So
Vanita Banerjee.
Hello.
sorry, sorry to interrupt again. This is Salman. Can I just take 1 minute?
Okay.
So we
Sure.
always talk about meltwater pulses, that these meltwater pulses lead to the cold climatic anomalies. But my question is
Yes.
about like what has lead to the melting? What was the that triggering mechanism that lead to the melting in North Atlantic? Was it just solar forcing or was there any other kind of mechanism?
See,
Can you
when
just
you
enlighten
talk
that?
it is not at all, not yet, I think, addressed, or maybe I missed it, but I believe the initial forcing that occurred, that 8.2 event that we've identified, it was because of the solar forcing, because this was a time when suddenly the Earth started experiencing more solar forcing and warming period. It was the onset of warming period. As because of that, there was a sudden throw of this yeah, in the ice water melted and it triggered in stopping the ocean circulation. So 8.2 rest, it has been seen as a cyclic process associated with the solar forcing. And of course, if some other proxies or other mechanisms, if it is acting, so to best of my understanding, I've not gone through any paper where other forcing mechanism has also been discussed. So till now, I would say it is the solar forcing that is acting on meltwater flux.
Okay. Thank you
Okay,
so much.
Okay,
thank you,
thank
Salman.
you.
So we have Dr. Vanita Banerjee. Please go ahead.
Yeah, am I audible?
Yes, Barnita,
Yes.
please.
Hi, Upasana. Very, very nice and
Hi,
informative
Barnita.
talk.
Thank you so much.
Yeah, I
Okay.
have just one. It's not a question, actually. It is something we should ponder upon. That
Okay.
you said that, the 8.2 kilo year event is not well
Mm,
recorded in Bay of Bengal. Am I right? And the possible explanation could be that the Bay of Bengal is often affected with the northeast monsoon. But
right.
is it established that now the northeast monsoon and the southwest monsoon, they are like anti-correlated? But was it always the same? Like maybe in the past they were not. They were in synchronization. So maybe the 8.2 kilo year event is not well recorded in the Bay of Bengal. Could be some other reason, isn't it?
That
Like we don't
it could be.
we yes, yes.
I think it could be some other reason. That was my assumption that because
Hmm.
Bay of Bengal experiences northeast monsoon, so that
Hmm.
I'm not saying ki 8.2 is not recorded. I'm saying
Not
ki
well recorded. Yeah, yeah.
not
Huh.
well recorded because it got diluted because of the northeast
Yes.
monsoon. And personally, I would say the northeast monsoon and summer monsoon, like winter monsoon and summer monsoon, they are primarily monitored by or triggered by the migration of ITCZ. So either of the ways, one has to be stronger and another has to be weaker. So they cannot be exactly equal. Maybe the rainfall could be equal, the amount of rainfall, because ISM causes more than 80% rainfall. So the migration ITC said is the position is in such a way that the rainfall amount may get equal,
Hmm.
but but they cannot be equally contributing. It's always an anti-process. One has to be strong.
No,
So
no,
this is my
Upasana. Yeah,
okay.
yeah. Actually, the northeast monsoon also depends. Actually, the southwest monsoon in India is very well studied, and the northeast is
Very
not.
well studied. It is
Yeah,
not. That's true. That is the
yeah, and
major
the northeast
drawback.
monsoon also depends on various factors, like it depends on ENSO. And when you showed that
Right.
Moy et al.'s curve, you see that the frequency of ENSO El Nino events was not that strong from 10, like in the early
From
Holocene.
10 to it's 10
Yeah.
to 7 kilo
Eh,
year. Yes, that's
Yeah,
true.
yeah,
That's
yeah.
true.
So, maybe because of various factors, the Northeast
Could be
monsoon
this reason.
was, yeah, they were not, and because in Indian East Asian, like East Asian winter monsoon and summer monsoon correlation and
Right.
anti-correlation has been studied, but not in India.
Oh,
So
okay.
I was just wondering that we could, like all of us, since we are all paleoclimatologists, we should ponder upon that
Exactly.
whether they were all always anti-correlated, or maybe they were
Or
correlated in the past. So we
actually,
should all think
personally,
upon it.
I would say कि whatever region that is experiencing winter precipitation,
Hmm.
exclusively winter precipitation without having any or less summer influence, that
Hmm.
those regions needs to be studied well because they are the ideal location to
Exactly.
address the
Especially
winter
Tamil
precipitation.
Nadu area. Yeah,
Tamil
yeah.
Nadu, exactly. I
Yes,
believe
yes.
that. Yes.
Yes, yes, yes. Very,
Yeah.
but overall a very nice talk and very informative.
Thank you so
Thank you
much,
so much.
Vamita.
Yeah, yeah.
Thank you so much.
Okay, so we have Dr. Ramanand Yadav. Please go ahead.
I may involve both the Dr. Banerjee and Dr. Banerjee because I have strong comments on the, especially your winter monsoon precipitation. Can you hear me,
Yes.
please?
Yes, sir.
Uh, Madam, I think I don't know the major studies. I feel it's literally difficult to justify the precipitation-based winter monsoon, especially from Bay of Bengal. Hope you
Okay.
will agree with me because if you see the monsoonal patterns, especially the winter parts in the Bay of Bengal, because churning the evaporation and precipitation and
Hmm.
distinguish from the summer monsoon is a difficult job. We need to
Okay.
look at other proxy like productivity and all, because how we can differentiate whether the in the past, because we need a very strong resolution to assess this
Resolution. That's true. That's
in
true.
the marine records. But if you're coming say for the cave record, it is maybe possible say for Momalu and all. If you enhance the your resolution parts, so that's the my
True.
comment. So you agree with me. It's a difficult job based on
Yes,
precipitation. Precipitation.
that's true.
So why
Yes.
why don't we, go for lakes in Tamil Nadu? I think they'll give good records for
Yeah,
Northeast
it might
monsoon.
be there. It might be there. But in the marine, it's difficult. What I'm feeling, maybe someone can record, but it's literally hard. Based on precipitation only. But if you're going for, say, other proxies like the weathering and all, it may give some proxies like productivity pattern. Thank you for presenting nice
Thank you.
talk.
Thank you so much.
Thanks, Dr. Ramanand. So anyone else? Okay, so before taking Anand's second, I think third question, I have some, I think one or two queries. This is a very basic questions regarding, I think all the newcomers who's working in paleoclimatology, I think they will correlate this with that. Uh, so if you see in the while when we are tracking the paleoclimate reconstruction in any time scale, especially
Mm-hmm.
because right now we are talking about the Holocene,
Mm-hmm.
the variation of all the proxies is not same. Suppose the one proxy is showing 4.2 kilo event, and it's not even showing the 8.2, but at the same time, the other proxy is showing 8.2 but not 4.2. So
Correct.
is it okay to say that the observation of getting these abrupt climatic events is very much based on the proxies and the resolution of
Yes.
the study?
it depends on. There are a lot of ifs and buts, I'll say. The first is it is the what proxy you're using or what archive you're using. Then what proxy record, is it a geochemical or is it an isotopic? So what proxy you're using. So ideally it would be great if you stick to one archive and one kind of proxy and then compare it. But the problem is we don't have all kind of archive or all kind of proxy in particular regions. Like it's the because of the that's what I said. Ki partial and temporal resolution is very much needed. Another is though I'm talking about Holocene, entire Holocene, but not all proxy will give me entire Holocene period. Some will give me up to 5,000. Some will give me up from 10,000 to 3,000. So that again, because every location need to have so uniformity should be there. Then only we can pinpoint a few interpretations. And another thing is interpretation wise. Suppose somebody is discussing about some event, but they miss the other. I'm not interested in that particular event. So that also gets missed. Like the Minoan warm period. It was during my PhD. I saw some kink in my data and I just reported it. I didn't know it was Minoan warm period or something. But when the same kind of monsoon event I saw in other core and in the southern core also, that made me understand that yes, there is some process, some event is there, but it is not reported in all the records. So that's how if we are just instead of accepting the fact that what globally people are saying, if we simply interpret our own data the way they are without directly connecting it with some event, then we might be discovering some new event in our record which is not reported anywhere else. So that is also very much needed.
Because sometimes I think most of the paper when you read, they directly just made one sentence that all the cold periods are showing this kind of like downward trend or upward trend. But
Exactly.
once you go to the but it means that not all the cold events are not the same. You
Are
can't
not the
assume
same.
all the HS period, and you can't assume all the cold periods like behaving in a same trend or same pattern. So that's what like because sometimes the reviewer asks why your data is not showing 4.2 kiloever event, but your data is showing 8.2 or other cold events. So I think this might be the one of the I think possible reason to I think how to tackle the reviews. And
Like
one thing, yes, please.
yeah, yeah, please tell me.
So and adding to the one question, one I think discussion which you had with the Partha, like whether these abrupt climatic events can like we can use this for future climatic I think interpretation. So my just one take on this is that right now we are still having very less information about the
Very
variation of
true.
these climatic events. And even if you see in the
Very true.
LGM, we totally assume like we are having a well-established knowledge of having like during the LGM it was cold event, summer monsoon was low, northeast monsoon was high, solar insolation very low. But in a recent study, I think there was a paper published in PNAS, and they found that there is a very nice cyclicity in between the LGM. In between the
Correct.
LGM, the summer monsoon is getting high.
Hi.
So when we are making like the simulation for the future climate, and if you're considering the LGM as a like cold event, you are just overlooking some factor that in between the LGM you are getting some solar insolation or you can say like high summer monsoon things. So that's why like we need to take care of while discussing or while making it like overall something. Yeah. So
Hello, Arvind.
That's true.
Hello,
yes.
Arvind. This is Salman.
Yeah.
Can you just highlight that paper? I am really interested in
Yes.
this.
Sir. Yes. Yes. Sir. I will send it to you. Don't worry. There's a paper in
Yeah,
PNAS, I think
you just message
2021, I
me.
think. Yes, yes, I will. I will. Thank you. So we have
Thank you.
Vireshwar, the next.
Hello, ma'am. Can you hear me?
Yes, Viresh. Yes.
Yes, ma'am. I'm Vireshwar from NGRI. So,
Okay.
ma'am, I have one question regarding the continuation. I mean, on the continuation of Mr. Salman's query. So,
Okay.
you told about that 8.2 kiloyear event that would happen
Mm-hmm.
like that's a result of the warming, like that North Atlantic ice melting. That is a result of your warming and that is also
Early
related
holes.
to the solar forcing, right?
Okay. Yes.
Okay, so but during that time, during that 8.2 Greenlandian period, that time the temperature goes down to, I mean, almost 4 degrees Celsius. So
Hmm.
which that time the record for from the Greenland ice core was that it is moving towards a more colder period from the Greenland ice cores. So how you explain this situation? You already told that that was solar forcing, that solar forcing ice melting was there at the Hudson Bay. But at the same time, the Greenlandian ice cores, they are actually showing the record of going down the temperature up to minus 4 degrees Celsius.
Okay. Now, the temperature which is going down minus 4 degrees centigrade Celsius, it is
Hmm.
during the 8.2 event, or it is around 10 kilo year, 10 kilo year or 9 kilo year.
So it is recorded during 8.2. In your paper, ma'am, I think
Exactly.
Banerjee,
Right.
if I'm not mistaken, it is Banerjee 2019, I guess. That's a review paper on the ISM and the Northeast monsoon. So
2020.
there you have
Yes.
mentioned about this 8.2 kilo event and the
Okay.
cooling event.
Okay. Now, when we are 8.2 event was the cooling event. Cooling event means the temperature will go down, right? And the
Yes.
minus 4 degrees centigrade that you are getting is during the 8.2 event and not the 10 kilo year. What I'm referring is the solar insolation, the high solar insolation, which started from around 11 kilo year and it continued. But because of extensive solar insolation, the ice melted around maybe before 8 kilo year, it got melted. No, I don't know when exactly it melted, but that melting resulted in cooling event of 8.2. It is not a one-day process. So when it reached to its lowest extent, that event has been reported as 8.2 kiloyear event, where you are getting 4 degree lower temperature. So when there is a cooling event, there will be lowering of temperature. But because of high solar insolation, led to such abrupt change. This would be my explanation.
So ma'am, that means you were saying that the melting of the Hudson Bay that is happening since your 11 that started from 11 kilo year.
I'm not saying it started from 11 kilo year. I don't know when it started, right?
Okay.
But this 8.2 was the time when the lowest temperature was achieved, or there was an abrupt change in the climate. That was the lowest time, and it continued for 160 years. It is not a longer time span. Like 4 kilo year, 4.2 kilo year was around 200 years, I believe. But it was a short period, 160 years. It's hardly a two-century climatic event that has been recorded. So it is more significantly observed in North Atlantic region, and for these signals to propagate in tropical, it will take some time. So it is always a it's not an abrupt of like temperature. What you're seeing is during that cooling event, and not during early Holocene when there was more solar insolation.
Uh, but ma'am, 8.2 kilo cooling that leads to, is that leads to Hudson Bay melting?
No, no, no. It happened because of the Hudson Bay melting, because ice melted and it fell into North Atlantic region, and it just stopped the ocean circulation.
Okay.
Because of that, cooling event happened. So
Okay.
it is not just 1 day process or 2 day process. It is the outcome of something. The 8.2 is outcome of that meltwater, that sudden freshening of water. It is the outcome of.
I think now
Got it.
we are running out of the time, and we need to conclude this session. But if Dr. Banerjee is ready, so we can take like one or two questions more, or if not, I think we can just sign off.
I'm okay with money. It depends on if people are
Okay,
asking questions, that I'm
okay,
happy that people will listen
yeah.
to
So
it.
yeah, so we have like one question from Jeet Majumdar, Dr. Jeet Majumdar. I think if you can access the chat box, you can read it.
1 second.
The last one.
Anyway, I was late. I missed my talk. Anyway, I have no one question. Did you so influence this?
already talked about this, but
Yeah.
you can just give a short.
4.2, 4.2 is mainly identified as weak summer monsoon, but I would say it is more recorded because I have a lake record where I don't see any 4.2 event, even though my time period is from 3,000 to 5,000 years. So I would say the 4.2 event is more significantly registered in case of northern and core monsoon zone, at least not the region which is experiencing the extensive southwest monsoon. This is my belief. Based on my record, I'm telling you. Regarding northeast monsoon signal, I don't know whether there was a stronger northeast monsoon, but since it was a stronger Siberian high, so I believe the Tamil Nadu or some records should show northeast monsoon. I'm not sure about the Arabian Sea. Arabian Sea has definitely shown 4.2 event as a weak summer monsoon, but Arabian Sea northeast monsoon record, I'm not sure about it since Dr. Rajoria has already mentioned about Tamil Nadu Lake. So that means Siberian high must have influenced the region that experiences northeast monsoon. So this would be my answer for that.
Okay, so I think now we need to just of this Q&A session because we're already running out of time, and whoever is having the questions, I think they can directly contact Dr. Banerjee, and we will just share this talk on the YouTube, and I think if she allows, so that I'll share her email to every one of you, and you can directly ask whatever question you have in your mind. And with this, I think we need to just say bye-bye to everyone. So thank you so much, everyone, and thank you so much, Dr. Banerjee, for having this such a nice talk and very informative discussion. I think the discussion went more than half an hour, so I think it was very great. And I just request everyone to just fill the Google form, which I will spread in the group. And thank you so much. Happy New Year to everyone, and we'll come with the
Happy New
next
Year to
talk
all.
by mid of the January. Thank you. Thank you, everyone.
Okay, thank you so much, Arun. Thank you all. Thank you so much.